Hi guys, today we are going to discuss about precision and importance of gyroscopes. Coming to the precision, what is precision? Precision is the phenomenon in which the axis of rotation of a spinning body means when a mass is mounted on the axis, then if the mass is going to rotate, then the axis on which this mass is mounted is axis of this body, which body is going to rotate. It is called spinning. Then the axis of spinning is spinning body is called axis of spin. So this spinning body is rotating with angular velocity omega s, let us say. Then if we have, let me draw other axis. Suppose perpendicular axis, this is, let us say, the spinning body is rotating about x-axis and there is y-axis and z-axis. Then if we try to move this body about any other axis, try to move this spinning axis along with the rotating body about any other axis, either z or y, then we need to apply a couple to move this. Then if suppose I am going to rotate this about z axis, then what happened? This spinning axis itself will, if I view from top, then I am giving clockwise movement. Then what happened? The spinning body will gets rotated some, let us say, angle delta theta in the time interval of delta t. Okay, so this type of motion, spinning axis along with the rotational body is getting rotated with any other perpendicular axis by applying some couple. Then this is called precision. I think you are able to understand. So I have taken here a disc mounted on the axis, x-axis, that means some rotor, for example, practical example. Then it is rotating with angular velocity omega s. This is called spinning velocity. Then enter this axis, if we move about z-axis, then that is called precision. So precisional angular velocity, how much we have given? We can say, we can notate with omega p. Then what is precisional angular velocity given? Delta t rotation with a time interval of delta t. This is delta theta by delta t is precisional angular velocity. So we are going to apply torque so that with the angular velocity of omega p, then we can say we have applied a torque which causes the axis to move at right angles to the applied torque. Okay, so right angles to the applied torque. So then the spin axis is moving. So let us take the notation of spin axis spin velocity, angular velocity of spinning body omega s, angular velocity of axis about rotation of axis about another axis is called precision velocity, precision angular velocity, and the couple which is produced due to this precision is called gyroscopic couple. Applied torque which is creates gyroscopic couple. Let us see more detail how we can calculate this gyroscopic couple. We can use this, we need to draw the vectorial notation diagram of these angular velocities to understand how gyroscopic couple could be derived. Let us say C is gyroscopic couple. Mass moment of inertia of rotating body is I. We know that mass moment of inertia can be expressed as I is m, mass of the body, into radius of gyration square. Okay. Omega is angular velocity of spinning body, omega p angular velocity of precision body. Now I will take this and I will show you why this gyroscopic couple arises. So this is spinning body is rotating. If I observe in front of this body front of the body, it is, let us say it is rotating clockwise. Then this is z-axis, this is y-axis. Then angular velocity vector as per right hand screw rule, then we have angular velocity vector of rotation of the spinning body. I can, because it is rotating clockwise. Clockwise means it is away from the viewer. Angular velocity vector. Are you able to understand? I think. Then I am going to rotate this spin axis along with this rotating body. From top I am rotating, let us say again it is clockwise. I am rotating. So then it is going to rotate. I am giving clockwise rotation. And let us say spinning angular velocity also going to change while its rotation. Delta theta rotation is given about z-axis in delta t time, and this spinning angular velocity changing from omega s to delta omega s. Then let us say starting omega s in the direction of rotation along the x-axis, let us say vector representing OA. And while you rotate with delta theta angle about z-axis by applying torque, then it is going to, spin axis going to move along with OB. That is the vector OB represent omega s delta omega s. Then how much change is given? The change is given is A to B vector representing the change of angular velocity. So this change of angular velocity, this vector represents AB. So AB can be, we can take in the both the directions, that is along omega x-axis, that is spinning axis, original spinning axis, that is, let us say this point is C. Then this is A. Okay. So then it is factorial sum of AC plus CB. So how we can write expression for this AC? AC is the difference between angular velocity along x-axis, that is spinning original spinning axis, that is initial angular velocity OA is omega s, we know, and final angular velocity, the difference I want to write AC, I want to find. AC can be written as OC minus OA. So what is OC? OC is, I can write omega s plus delta omega s into, this is delta theta, so cos delta theta, minus OA. OA is initial angular velocity of spin. So this is omega s. This is change in angular velocity. I want to find rate of change in angular velocity. Rate of change in angular velocity. Okay, this is, I need to divide it with the time. Okay, so this is, we can simplify this expression and we can have omega, this is, if, see, time interval delta t limit tends to 0, then very small time interval, then we have cos delta theta equal to 1, we know that. Then we will have finally remain with delta ws by delta t. This represents rate of change of angular velocity, that is along the direction of spinning axis. Now coming to the other component CB. What does it CB represent? CB is omega s plus delta omega s times sine delta theta. Okay, so initial angular velocity in that direction is 0. Okay, so then by rate of change of angular velocity in that direction, perpendicular direction, I want to find. Then, okay, rate of change of angular velocity. CB is this numerator, and rate of change I want to divide with delta t. Then if we simplify this again, we are going to get if sine delta theta, the delta theta is very small, sine delta theta becomes delta theta. Then we can neglect product of two small terms delta ws delta theta. Then we can write it is ws times delta theta by delta t. This is rate of change of angular velocity in the direction C towards B. Okay. Then this is representing angular the rate of change of angular velocity. Rate of change of angular velocity as per definition is, we can say it is angular acceleration. So there are two components of angular acceleration. One is along the direction of rotation of spinning axis. Other one is along the direction which is perpendicular to the spinning axis. So spinning axis rotating clockwise direction when view from in front. Then if you try to rotate with delta theta angle delta t time about z axis, then we will have arrived the angular acceleration vector, that is CB, from representing C towards B. So T, as per right hand screw rule, C towards B means it is equal to about y axis. If you rotate that entire spinning body clockwise, if you view from in front, about y-axis we are rotating clockwise. Means this effect, the rotation about clockwise, which is called gyroscopic action. Gyroscopic action, or it is gyroscopic couple. Gyroscopic couple. The couple which is applied equivalent is written as angular acceleration, moment of mass moment of inertia times angular acceleration applied, angular acceleration exists in that direction. That is, this angular acceleration I am going to represent with alpha. Let us say it is I alpha. This is gyroscopic couple. So this gyroscopic couple, what happened? Because it is going to tend the axis spinning body to rotate clockwise. Clockwise means it is moving down. Axis of spin is moving down. So vectorially, this is, we can say that the spinning body axis along with the body is moving down. Then reaction part, if you go coming to reaction part, then it is, because it is moving down, there will be a reaction on the frames of the bearings and frame. Then that is going to, that reaction going to move it, try to move it in opposite direction to maintain the stability of the body. I think you are able to understand gyroscopic couple. We arrived is I into alpha is, this alpha is omega s, delta theta by delta t is omega p. So overall gyroscopic couple is omega s times omega s spinning body angular velocity times precision body angular velocity. You are able to understand. This is very, very important if you come to real time applications. Let us take example automobile. The wheels are spinning. Automobile, while it is moving, wheels are spinning, and also engine parts in the automobile are rotating. So along with this, entire automobile is going to take a turn, either left turn or right turn. Then it is the effect of gyroscopic action or gyroscopic couple. The vehicle is going to tilt. So then we need to, there is a reaction. It is to maintain stability of the vehicle, there will be a opposite direction of reaction is occur. That is called reaction gyroscopic reaction against the action to maintain stability of the vehicle. That is important to study in case of automobiles. Similarly, in case of we can take a ship. Ship is having motor rotating elements to propel it ship and move forward. Then if ship is taking a turn, because already rotating engine, rotating motor is there, then it is rotating, while rotating simultaneously it is taking a turn. Then there will be a gyroscopic effect on the ship. It may along the perpendicular axis, it may tilt. So we will study in detail ship separately, what are various terminology involved in that. So precision is very important to maintain stability of the vehicles and in aircrafts also. So there are engine rotating elements, turbine, rotor rotating, okay, in along the one axis of the axis it is rotating, but entire aircraft is going to take a turn, left turn or right turn. Then there will be a gyroscopic couple effect. Then aircraft will going to take tilt, and to maintain balance there will be a opposite reaction, gyroscopic action and reaction should be there. So, and in case of ships, marine engineering, and in case of aircraft engineering, in case of automobiles, these are gyroscopic effect is need to be considered while analyzing the dynamic force analysis. So now coming to the I think you are able to understand. Let us take one small example, then we can understand how we can able to analyze the problem and how we can able to predict the movement of the system, that is aircraft or automobile vehicle or ship. Okay, so then coming to the you have seen already. This is another approach that we can discuss sometime. Then let us take a problem on aircraft. If aircraft is flying with a speed of 300 km per hour. So what is this 300 km per hour along a circular path of radius 150 meters? What is this 300 km per hour? It is flying at a speed of 300 km along a circular path of radius. So it is taking a turn, it does mean. So radius of this circular path is, it is taking a turn. Aircraft is taking a turn. And it is radius of the circular path is 150 meters. This is the radius. Let us say R 150 meters. R is 150 meters. Then R is 150 meters. Then what is the velocity it is moving? Speed of the aircraft 300 km per hour given. We know that how to convert into meter per second. So it is 1000 by 3600. That is 5 by 18. We can multiply. We can get it. Then the aircraft engine rotates at 2400 RPM. So what is that aircraft speed is okay? V, let us say. Then aircraft engine rotates at 2400 RPM. What do you mean by the engine is spinning, rotating 2400 RPM. Then spinning velocity, angular velocity of the body is, we can find 2 pi n by 60. So we can find angular velocity of spinning body. And similarly, what is the precision? Taking a turn means about perpendicular axis, it is given angular motion. Then we need to find frictional angular velocity, omega p, which can be found by writing V by R. Because V is omega R, you know that. Then V omega p you can find. Then gyroscopic couple, moment of inertia of this rotating bodies are given. Then this is I, omega S, omega p. You can find gyroscopic couple. So vectorially we can understand how the aircraft is going to rotate because of this gyroscopic effect. So spinning axis, it is said 2400 RPM clockwise when viewed from the rear. From rear end of the aircraft, if you observe, then it is spinning axis rear end clockwise. Clockwise rear end means it is the angular velocity vector moving away from the viewer. Is it or not? Spinning axis. So then it is, let us say OA represent angular velocity vector. Then this, it is taking a curve 150 RPM. It is given curved path 150 RPM. Aircraft flies at a speed let us say it is taking left turn. Then left turn means this entire spinning axis is going to be rotated. If you see from above, it is anti-clockwise movement. Delta theta angle. Delta theta by delta t is equal to omega p. Okay, delta theta angle. Then if you see, this is, let us say, after rotating, the position of the spinning body is, okay, OB. Then change in the angular velocity is vector representing A to B. So that is gyroscopic couple which causes the rotation, because it is A to B, means its rotation is clockwise about other perpendicular axis. So this is the nose end of the aircraft is going to move down, and because of gyroscopic couple, and tail end move up because it is clockwise. Then reaction on against this, to maintain stability, nose end will move up and tail end will be move down. This is reaction is opposite direction. So these problems are very simple to attempt, but once you understand the way, we can see that the rotating body is a vectorial representation, and spinning you are giving, okay, anti-clockwise rotation, this entire spinning axis. Then the change from starting A to B vector is this one. This is gyroscopic couple, which is, if you rotate clockwise, then only it is vector A to B. So reaction is opposite direction, B dash to A dash. So in that way you can understand what is the effect of gyroscopic couple on the aircraft, what is the effect of reactive couple on the aircraft. To maintain balance, aircraft will be stability maintained, and horizontal position it will move even though it will take a turn. This is about aircrafts are concerned, gyroscopic couple influence, and now we will discuss in coming lectures the automotives, the gyroscopic effect, and in marine engineering ships, the gyroscopic effect. For that you need to understand some important terminology involved in those areas. Okay, thank you one and all. With this I am concluding this lecture. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.